welcome to today's lesson. Today we are on Unit 2, Lesson 1, so 2-1. Our objectives for today are to determine the domain and range of a function graphically. Our language objective is to explain how to find the domain and range of a function's graph. So let's take a look at today's Do Now. For today, you're going to identify the input and output given the following table. Represent your answer in roster form. So really quickly, roster form is a list that you're going to make. So I'm going to pause this and I'm going to quickly make you guys do the input and output for the given table. All right, so here are my input. The input are obviously all of the X values, which you all know. I listed my numbers out and then I put curly brace. So make sure you put curly brace around the list. Your output value, same thing, right? The Y values in order I put it is already in order with curly brace at the ends. So let's see what we're doing today. For today, we are going to start off by defining some definitions that you have already talked about in previous math and then apply them to our lesson. So we are going to be thinking about what is a relation, what is the domain and range of a relation, how do we know the relation is a function? So those are our main focuses. And before I answer any of these, I am going to define some of them. So a relation. In 9th grade, you learned about relations. A relation is an equation with two or more variables. What is the domain? The domain are all the possible X values, also known as the input. What is the range? The range are all possible Y values, which are our outputs. What is a function? A function is when the domain does not repeat. And lastly, we have interval notation. So how do I represent my numbers or my answers using interval notation? We're going to see brackets and parentheses. Brackets just mean that the number is included, and parentheses mean that the number is not included. All right, so that is some of the definitions that we're going to need to do our lesson for today. So let's look at example 1. And in this example, we are asked to identify the domain and range of a given relation. So for number 1, we have state the domain and range of the given relation in roster form, which just means a list. So I'm going to quickly do that. So if I represent the domain, I'm going to do capital D with a colon. The range would be capital R with a colon. Just so you know, instead of me writing out the word. So I listed out my domain, I listed out my range. I'm done with the first piece. The second part asks, state whether the relation is a function or not. Explain. So a function means that the domain does not repeat. I'm focused on the domain, and here clearly I see that the numbers do not repeat. Therefore, we do have a function. So function because the domain does not repeat. Nice and easy. For number 2, state the domain and range of the given relation written in interval notation. First thing I want to identify is my function. I'm going to focus on it. Here I see a vertical line. This is not a function, so let me correct myself. I have a graph. So the domain of this graph, what are all possible X values I could have? I only see one possible X value, and that is the number 2. But using interval notation, we have to use brackets or parentheses. Brackets mean that the number is included. So that's how I will represent my domain. A little bit weird looking. My range, what are all possible Y values I can have? Now, I see that this graph keeps going on forever and ever on both sides. So the smallest possible Y value I could have is negative infinity. The largest possible y value I could have is infinity. And what do I wrap this infinities with? I have to put parentheses. Infinities are never included. All right, so that was kind of like a little review. Let's look at the next piece. There are different ways of us representing our answer. How do we write our answers in different notation? There's something known as set notation, which we did talk about in the beginning of the year. This is also known as set builder notation. So I wrote something there. It says x such that x is a real number. So if you're writing set notation, you're going to start off with curly brace. You're going to say x such that, which means this line, and then you're going to input the inequality, whatever that inequality might be. And that actually leads us to our next piece. We have something known as inequality notation. Inequality notation is simple because it's literally an inequality. There's different types of inequalities you could see. X greater than 4. You could have x less than or equal to -5. Or you could have a compound inequality. What's a compound inequality? Let's say smallest x value is -2. Largest x value is 4. So here I have a compound telling me that -2 is the smallest, but that -2 is not included. And it's telling me that 4 is the largest and 4 is included because of the or equal to. So kind of refreshing your mind on your inequalities. Now that we know these types of notation, we're going to actually apply them. So for example 2, identify the domain and range of a given function. For each, identify the domain and range of the following using interval notation, set notation, and inequality notation. So we're going to do all 3 types of notations that you can be asked to represent your function as. For this first one, I'm going to look at what I have. I have a function, square root function, and my function starts and goes on forever, right? It starts at that point, looks like -2, 4, and goes on forever on the right side. So let's start off with interval notation. I'm going to say int notation for short. So we're going to represent the domain and the range. So what are all the possible x values I could have? I see that the smallest x value I could have starts at -2. And is -2 included? Usually this is the process that I walk through myself when I'm looking at a function. And I see that there's a point there, which means that that function, that -2 is definitely included. So bracket. And where does this function stop? What x value does it stop at? Paying close attention, I see an arrow, which is telling me that it's never going to stop. So the largest x value you're dealing with is infinity. And infinities are never included. All right, same process for the y's. So my range, what is the smallest possible y value I can have? Here's my y's. So that means 4. And is 4 included? Yes, because I have a point at -2, 4. And what is the largest y value I could have? Again, this arrow is telling me that it's going on forever. Therefore, my y's are also going to keep growing slowly. Therefore, my range goes from 4 to infinity, including 4, not including infinity. Okay, so now I did the first piece. Next thing I'm going to do is my inequality notation. Okay, so same thing. I'm going to identify the domain and range. I'm going to ask myself the same questions, right? My domain, what is the smallest possible domain? Where does it go? I already know what the domain is because I did it for the interval notation. So I'm trying to figure out how can I represent this domain as an inequality? What does this domain mean? It's telling me that x is greater than or equal to -2. X, the domain, keeps growing and growing and growing after -2. My range, I do the same way. I look at my interval notation and I ask myself, how can I represent that range as an inequality? What does this 4, including 4 all the way to infinity, mean? It means that we're talking about all the y values that are greater than or equal to 4. Last notation. The last notation is easy because I already have my inequality set up. So my set notation, domain and range, is going to look very similar to that inequality. So I'm going to start with curly brace. Domain is x, so x such that, and all I do is input that inequality I have there. For my range, curly brace, y such that, and I input that inequality I have there. So I tend to do it in this order. If they ask me for all three, I start with interval notation, I do inequality next, and the last one I tend to work with is set notation. So let's look at a different graph, a different function. So we're going to start off with interval notation. And here I have a more complex graph. So I have the first piece here. So I'm going to look at just that piece alone. What is the smallest possible x value for that yellow highlighted piece? The smallest possible x value I could have is at negative infinity. And again, infinities are not included. For the yellow piece alone, what is the largest x value I could get to? It looks like 3, but is 3 included? No. Why do I know that 3 is not included? When I draw this little invisible line here, I know there's an invisible line there because I have two functions that are right on that same path. Only one is going to the negative infinity side and the other is going to positive infinity side. So this should take you back to a graph you have seen in your A2 classes dealing with asymptotes. We will focus on them later on. Okay, so we are going from negative infinity to 3, not including 3. I'm going to put this little u because it is a union. There are different pieces to it, but there's still a union. Let's do pink next. Here's my second piece. And I'm going to ask myself again, what or where is this function going from? It's going from 3, not including 3, all the way to 8. Again, not including 8. There's another invisible asymptote there. I'll draw it in. Union, our last piece. Here's our last piece. And for our last piece, where are we going from? We're going from 8 all the way to infinity, not including 8 because we're dealing with the asymptote, and going to infinity, and infinities again are never included. Okay, so now we have the domain. Now we need to look for the range. For the range for this specific function, we are not looking at it individually. I'm actually looking at this pink piece, the in between. That pink piece touches every single y value whatsoever, which means that the range goes from negative infinity to infinity, all possible numbers. So there's my first notation. Next notation I'll do inequality. Again, just like before, I have 3 different pieces, which means for the domain, I'm going to have 3 different inequalities. So I'm going to start with the first piece I had. The first piece went from negative infinity to 3, which means that we're dealing with all the x values that are less than 3. Instead of a little u, we write or. So my second piece, what is the inequality for that? All the numbers from 3 all the way to 8. So 3 is the smallest, less than x, less than 8. There's my compound inequality. Or the last piece that we have here goes from 8 to infinity, which means that that is x is greater than 8. There's my 3 pieces. How do I represent that range? Now, what does negative infinity to infinity mean? It means all numbers, all real numbers. So if I'm representing that as a inequality, we'll say y, this e, exists in the set of reals. So something that we did in the beginning of the year when we were solving. Last type of notation, set notation. Now that I have the inequality, I'm just pretty much going to copy it. We have x such that. I'm going to input my first piece, comma, second piece, comma, third piece, curly brace. My range, curly brace, y such that, and that inequality. When you are doing the domain and range, you must always put it from smallest to largest. You cannot work backwards. You cannot just mix up your order. It has to be in order from small to big. Last question. So for this question, we have our graph highlighted. We're doing all three inequalities. I'll do the interval notation with you guys, and I'll have you guys do the next two. All right, so we have our domain. For interval notation, smallest possible x value I can have is negative infinity. Largest possible x value I can have is infinity. The range, what is the smallest y value you could have? Looks like 0, but it's not including 0. Again, kind of going back to your knowledge that you learned about exponential functions. Exponential functions have horizontal asymptotes, and here they kind of dotted it, so that means there's an asymptote there. So it goes from 0 to infinity. So I'm going to make you guys do the inequality notation and the set notation for this one, and let's see if we have the same answer. All right, so here's my inequality notation. We're dealing with x exists in the set of reals, and my range would be y is greater than 0. For my set notation, x such that x exists in the set of reals, and my range would be y such that y is greater than 0. When you are dealing with these graphs, pay close attention to the pieces you might have. Look for those asymptotes. Sometimes they're clearly labeled. Sometimes it's just based on your knowledge of your functions that you have dealt with in the past. So keep growing, keep learning, and I will see you in our next video.